Hello guys, welcome to my channel Engineer Star. Today I will be discussing about 3 reservoir problem. It's numerical, type hot numerical. So this is the question. Following is the data for 3 reservoir systems shown in figure below. Determine the discharge through each pipe. Take F equal to 0.02 for all pipes. There is given 3 reservoir A, B and C with their water surface elevation 120 meter, 100 meter and 80 meter. So this is we write in given. There are 3 pipes which connect reservoir A, B and C to junction J, which diameter and length are given. So first of all we write the given length, diameter and elevation, and this friction factor is also given 0.02 meter for all 3 pipes. So F equals 0.02. So determine the discharge through each pipe. We have to find the discharge. So Q1, Q2 and Q3. First of all, we calculate the value of R. For first pipe, it is given by 8F L1 divided by pi square G D1 power 5. F is 0.02, L1 is 240 and G is 9.81 and D1 is 300 millimeter divided by 1000, that gives 0.3. So the value of R1 is calculated. So similarly the value of R2 and R3 is calculated. So this is reservoir A, this is datum line. So elevation is given in question. Z1 is 120 meter, similarly Z2 and Z3. So this is reservoir A, this is reservoir B and this is reservoir C. So pipe 1 connects reservoir A, pipe 2 connects reservoir B and pipe 3 connects reservoir C to junction J. So water always flows from higher elevation or higher energy level to lower energy level. So water flow from A to J, similarly from J to 3. The datum head of junction J is ZJ. So here let us assume ZJ as J is total head at J, so which is so we assume it as 100 meter. So that's F1 means head loss in pipe 1 is given by total head at 1 or A minus head loss at minus total head at J. So H1 means total head at 1. Let me write something. Total head at 1 is H1 is equal to datum head, that is Z1, pressure head, that is P1 upon rho G or gamma, plus velocity head V1 square upon 2G. So pressure is atmospheric pressure, so gauge pressure is 0, and velocity at here is also 0 because the reservoir is large, so its diameter is large compared to this pipe, so fall off level is very small. So square of since velocity fall of this level is very small, that means velocity is small. Its square is much small, and divided by 2 and divided by 9.81 gives negligible value, so this term is nearly equal to 0. So H1 equals to Z1, so F1 is equal to H1 minus Hj, and since H1 equals to Z1, so we have write Z1. So Z1 is 120 minus Jj is 100, so head loss in pipe 1 is 20 meter. Then we know the formula. H1 equals to R1 into Q1 square. F1 we have calculated 20 meter, R1 we have calculated 163.14. so from this we can calculate Q1 as 0.35 meter cube per second, and F3 means head loss in pipe 3. It's given by total head at this junction, that will be maybe here, total head minus J3 means this, so head total head at J minus this J3 gives head loss in pipe 3, that is 100 minus 80, which is 20 meter. So by using this formula, HF3 is 20, R3 we have calculated, so we can calculate the value of Q3. So from this Q1 and Q2 we notice that Q1 is higher or more than Q3, that means this discharge is more than this discharge, so the sum of the discharge will go here, so water flows from J to B, so we can write Q1 equals Q2 plus Q3. Since Q1 greater than Q3, Q1 equals Q2 plus Q3, and water flows from J to B. Since water flows from J to B, so total head at J must be greater than total head at 2, so J greater than J2. So I have given the direction. So this is the iteration table. This is first iteration, this is second, this is third, and this is fourth iteration. In first iteration we have assumed the value of J at 100, and we have calculated this this and this as q1, q2 and q3. So q2 from previous slide we have written q1 equals q2 plus q3 by the conservation of mass and density is constant for water. So q1 equals q2 plus q3. So by rearranging, q2 equals q1 minus q3. So q2 minus transferring this term to left hand side, q1 minus q3. So here remains 0. So by this continuity equation we have derived q1 minus q3 should be equals to 0. So if this value comes near to 0, then we stop the iteration process. So q2 minus q1 minus q3 is negative here. That means q2 is less than this q1 minus q3. So to make 0, we have to increase q2. To increase this q2, we have to increase head at junction J. So we increase to 105. So we calculate this and it comes to be minus 0.070, and again q2 is less than q1 minus q3. So we slightly increase head at J because it's nearly equals to 0. So we slightly increase by 1 meter. So again we calculate this. So it gives positive means q2 is greater than q1 minus q3. This q2 is greater, so we have to decrease to make the discharge 0. So to decrease q2, we slightly reduce the head at junction J to 105.5. So by this way the difference is nearly equal to 0. So we stop the iteration. So q1 is taken from here, q2 is taken from here, and q3 is taken from here. So thanks for watching. Like the video, share the video and subscribe, and finally follow me on social media.